Good morning, evening, afternoon, or whatever time you are watching this video. Mr. Simonian here. Today, we're going to be talking about vectors, a topic that's going to come up over and over again throughout physics. And specifically, we're going to learn about some of the basics about drawing vectors and vector diagrams. And then we're also going to talk about how you can add and subtract vectors in one dimension. So that's what we're talking about today. The objectives are to use properties of vectors as well as the rules of addition and subtraction to add and subtract vectors, providing the correct answers with the correct units. Just to quickly review, a scalar quantity is a quantity that has magnitude but has no direction. So examples of scalar quantities would be like mass, temperature, and time. Vector quantities are quantities that have both magnitude and direction. So a good example of that is a force. If you've ever tried to push open a door or hammer a nail, then you have some experience about how the direction that you apply that force matters. When we talk about magnitude, that's just the number or the amount or the size of the quantity that we're talking about. And then direction is the way that that quantity points. And you might describe it as positive or negative. You could use cardinal directions like north, east, south, and west. And you could also use an angle. But right now, we're just going to stick to one-dimensional. So that would mean either moving just to the right or to the left, or in one of the cardinal directions. So let's talk a little bit about what we need to think about when we're drawing vector diagrams. The first thing to know is that vectors are represented with arrows. So these arrows look just like you would expect. They point in a certain direction. And so whenever we're drawing vector diagrams, we represent the vectors with arrows. So in any vector quantity is going to have like a name, and so, or it's going to have a symbol rather. And whenever you draw vectors, with the symbol, you have this little hat or this little arrow that's on top of the vector. So basically, whenever you draw vectors, the vector symbol has an arrow on it as well. And that's just to help you know that this quantity is a vector. That means that you could just write the quantity A with a hat on top of it, and you would know that we're talking about this vector. Whenever you're drawing a vector, the vector is drawn pointing in the direction of the vector. So the vector points in the direction of the vector. Whenever you're drawing these vectors, it's really important that the direction that you're drawing the vector is actually the direction that that quantity is pointing in. So for example, if you have a vector that's pointing due north, then you want to make sure that that vector is pointing to the north. If you have a vector that's pointing to the east, then you want to make sure that you're drawing that vector on your diagram pointing to the east. Same thing with the south, and same thing for the west, right? Any vector needs to point in the same direction as the quantity that is the same direction as the quantity that it's representing. And cardinal directions are a good example of that, right? So you can imagine that we're looking with a bird's eye view on top of some situation. And if you've got a particle moving to the north or to the south or to the east or to the west, then you would want to make sure that it's actually that you're drawing those quantities in the same direction that the quantity is actually moving in. So that's another thing that we need to know. The third thing that we need to know about these vector diagrams is that the length of the vector tells you about the magnitude. So the length of the vector, when you draw it, it tells you about the magnitude. So up here, I drew this vector A, and I could create a new vector called B that is twice as large as A. So if I have a vector B that's twice as large as A, then I would draw the vector B with approximately twice the size of A, so that you can imagine that I would have to do A and A, that the vector B would have a size that is 2 times the length of A. Oops. That's the other thing that we want to know about these vectors, right? Whenever we're drawing them, we want to make sure that we're drawing them to scale. So that means that if one quantity is if one quantity is twice as big as another, then we want to make sure that we're representing that vector appropriately in terms of its size being twice as big as the other one. And then another thing that we're going to be able to do, at least one thing that'll work for us in physics, is that vectors can be picked up and moved around. So just like I took this vector A and I moved it right here, vectors can be picked up and moved around. The only thing that you have to make sure, so you can do this as long as they keep their magnitude and direction. I can take this vector A and I can move it here, I can move it here, I can move it anywhere, as long as whenever I put it in that new place, it has the same magnitude and is pointing in the same direction. And that's another thing that we can do with vectors. And all of these things, we're talking about this right now in so much detail because for most of the physical quantities that we're talking about, or at least a good percentage of them, they're going to be vectors and they're going to have these kinds of properties. So we want to be able to know how they work on diagrams, and we also want to know how we can add and subtract them whenever we are dealing with vector quantities. So that's where we're going with this. The next thing I wanted you guys to do is just to check and make sure we're getting this. I wanted you guys to try a ranking question. So basically, this question is saying 5 vectors are shown superimposed on a grid. And the question is, you want to rank the magnitudes of the vectors from the greatest magnitude to the least magnitude. And so what you should do is pause the video right now, give this question a try on your own, and just try your best to get the answer, or at least try your best to finish the question. If you have an answer or you get stuck, then press play and follow along and try to check your work. So pause the video now and come back when you have an answer or if you get stuck. All right, so hopefully you were able to get this one right. On the grid, the important thing to remember is that these vectors, the length of the vector tells you about the magnitude. So what I would do is I would just look at this problem and I would just go in and I would just count the magnitudes of each vector. So vector A has a magnitude of 3. And remember, the magnitude is just the length. It doesn't have anything to do, the magnitude and the direction are separate. The magnitude is the length, the direction is which way it's pointing. So the magnitude is just the length. So vector B would have a length of 1, 2, 3, 4, 5. Vector C would have a length of 1, 2, 3. Vector D would have a length of 2. And vector E would have a length of 1, 2, 3. So then ranking them is just a matter of saying B was the greatest, and then you had A, C, and E. These were all equal, right? So you could put those in any order. B was bigger than all of these, and then all of these were bigger than D. D was the smallest. So hopefully this was the order in which you wrote these terms. These symbols are just letting you know that B was bigger than all of these, A, C, and E were equal, and and all of these were still greater than D, which was the smallest. So very often what we're going to end up with in physics is we're going to end up having two quantities that are vector quantities, and we're going to have to add them together. So I want to talk about how we can add vectors just when they're in one dimension. So let's say we wanted to add A and B, those two vectors that we were talking about before. And actually, instead of writing A and B, I'm actually going to write it as A plus B, because really that's the operation that we're doing. We're adding A plus B. And if you want to add A and B together, what you do is you you place the vectors head to tail. So you would bring down that vector A, right? Because you can always move those vectors around. So you would take that vector A, and whenever we're talking about the head and the tail, this is the head or the tip, and then this is the tail. So when you're placing them head to tail, the order matters. So if it's A plus B, then you're laying down vector A, and then you're placing the tail of B at the head of A, or you're placing the tail of B at the tip of A. You could say it either way. So then we're going to bring that vector B down here, and we're placing those vectors head to tail. Whenever you add two vectors, you get a new vector, and that is called the resultant. So the sum of two vectors, and that when you sum two vectors, it has a name, and that's called the resultant. So the sum of two vectors is called the resultant. And that resultant is a new vector. And it's the vector that you get when you go from the tail of A to the tip of B. So this is when you add two vectors, you get a new vector that points in the same, well, in the direction of that vector tells you how far you moved, or is telling you about the orientation of this quantity, and then the size is telling you about how big it is compared to the originals, or where you're going, or it depends on the context, but A plus B is going to be a vector that looks like this. And that's one of the important things to know is that just like when you add two numbers, you get another number. When you add two vectors, you get another vector. So this new vector, the resultant, is called A plus B, and it's a new vector. So the resultant is a new vector. And we draw it just like we would draw any other vector. So like an example of what this might be is like if you're starting at your house and on your way to work, you first stop and get some food. So you go 10 miles to the east. You start at your house, you go 10 miles to the east, and you get some food. And then you go 20 miles to the east, and then you get to work. So the vector a plus b, the resultant, is your overall trip going from your house to your job. This is how far you went overall and the direction that you traveled in. That's like an example of what these vectors might mean whenever we start actually giving them a physical context. And it's important to also note that whenever you're adding vectors, the order, it doesn't matter what order you do it, you would still get the same result. And what I mean by that is if I were to have done B plus A, if I wanted to add B plus A, then I would place B down first, and then I would place the tail of A at the tip of B, and then my resultant would be what I get when I go from the tail of B to the tip of A. So this would be the vector B plus A. But notice that A plus B and B plus A, they end up being the same thing, right? You end up having the same size and the same direction. So that's just an important thing to note with whenever you're adding vectors, is that if you're doing A plus B, or if you're doing B plus A, the result is the same in terms of what the resultant looks like. You get the exact same vector with the exact same size pointing in the exact same direction. In other words, it doesn't matter if you go 20 miles east and then 10 miles east, or if you go 10 miles east and then 20 miles east. The overall result is that you ended up 30 miles east of where you started. So that's vector addition. And what we would say here is it's the same thing with when you're adding two numbers, is that it doesn't matter if you do 5 plus 10 or if you do 10 plus 5, you're going to get 15, right? So it doesn't matter the order that you add two numbers, you're always going to get the same result. It's the same thing with vectors when you're adding them. And so the last thing that I wanted to talk about is subtracting vectors. And before we really talk about subtracting them, it's important to note that vectors can be negative. Let me fix my handwriting, sorry about that. Vectors can be negative. And that means that when a vector is negative, they will have the same magnitude. They will have the same magnitude and opposite direction. So, and if a vector is negative, you can write it by just putting a negative sign in front of it. So like, let's go back to our good friend vector A. If we wanted to talk about negative A, then we would write the vector A with the same magnitude, but just pointing in the opposite direction. You could also imagine that if there was some vector called C that was oriented like this at some angle, that the vector negative C would have the same magnitude, but would just point in the opposite direction of its original vector. Yeah, so yeah, I guess it's important to just note that when we're talking about vectors can be negative, they'll have the same magnitude and opposite direction as the original vector that you're talking about. Like earlier, the original vector was A. So here we're talking about negative A is in the same, it has the same magnitude as A, but is in the opposite direction as A. And then I guess just to kind of drive the point home, we can also talk about that our old friend vector B. And if we had a negative vector B, then that vector would just be pointing in the opposite direction, but would have the same magnitude. It would still be twice as large as vector A, but it would just be pointing in the opposite direction, to the left instead of to the right. And so that's really helpful for us because whenever we're subtracting vectors, like say we wanted to subtract A from B. If we want to subtract A from B, it's helpful to rewrite it with a negative. So it's helpful to rewrite it with a negative number instead, or with a negative vector instead. So in other words, you could just as easily, instead of saying A minus B, you can say A plus the vector negative B. And what that means is that we already know how to make it. We just talked about how we can make a negative vector, right? Making a negative vector is pretty easy. All you do is you rewrite the vector with the opposite direction. So we're just, with a negative vector, you're just rewriting it with the opposite direction. And then because now you're adding the two vectors, because now you're adding A and B, then you're just gonna add the vectors normally. Add vectors the same way you would normally add them. So let's see what that would look like, right? If we're doing A plus negative B, then we're gonna write out the first vector, which is A. And then we're gonna place the tail of B at the tip of A. So in other words, we're just gonna take this vector and we're gonna move it down here such that the tail of the vector negative B is at the tip of A. So that's the vector negative B. And then when you add the two vectors to find the resultant, you go from the tip of A to the, you go from the tail of A to the tip of B. So whenever I add these two vectors together, I go from the tail of A to the tip of B. And that right there is my vector A minus B. Again, just like when you add two numbers, you get a new number. When you subtract two numbers, you get a new number. So when you subtract two vectors, you also get a new vector. What this is effectively telling you is, like, imagine if you moved 10 miles to the east, and then you moved 20 miles to the west. A minus B would be your overall trip, how far you ended up moving overall, which was 10 miles to the west. If you started here and you go 10 miles this way and then 20 miles that way, overall, this is telling you how far you ended up to the left. You ended up to the left with this magnitude of distance. So the important thing to note with these when subtracting vectors is that you don't get the same thing if you switch the order around. Just like if you have 10 minus 5, you get 5. But if you switch the order, you get something different. So if you have 5 minus 10, then you get negative 5. So with subtraction, the order does matter, and it's the same thing when you're subtracting vectors. So if you were gonna do this in the opposite order, in other words, if you wanted to do b minus a, then that would be the same thing as taking the vector b and adding negative a to it. So if you wanted to do that, it would look something like this. You're starting with the vector b that was in its normal orientation, right? So our vector b is going to be about that size and in that direction. So here's my vector b. And then my vector negative a is going to be this big, but is going to have the opposite direction. So, and whenever I add these two vectors, I would start at the tip of b, and I would place the tail of vector negative a at the tip of b. So my vector negative a would look like this. That's the vector negative a. And so to go to find the resultant vector, I go from the tip of b, sorry, I go from the tail of b to the tip of a. So I go from the tail of b to the tip of a, and I get, and this is my resultant b minus a. And notice that just like whenever I was doing the example with 10 and 5, doing 10 minus 5, I got a positive 5. Doing 5 minus 10, I got a negative 5. So the difference between these two numbers was just a negative sign. It's kind of the same, well, it's the exact same thing here with these vectors, in that the difference between a minus b and b minus a is that they have the same magnitude. At least they should have the same magnitude if I drew it perfectly to scale. But so these two vectors should have the same magnitude, but they have the opposite direction, which is the same thing that you see whenever you're subtracting two numbers. So that is what I wanted you guys to know about the basic properties of vectors and adding and subtracting vectors. We're going to get a lot of experience doing vector addition and subtraction with different physical quantities throughout this year. So I wanted to just, before we did any of that, make sure that we had a kind of conceptual understanding about what it means to add vectors and subtract vectors before we actually put the physics numbers and symbols behind them. So thank you for your time. Thank you for your patience. And we'll be seeing how all of this stuff about vectors gets applied in physics the next time in class. So thank you guys for your patience and your time. Hope you guys have a great day. If you have any questions, feel free to let me know. Thanks. Take care.